Hello everyone, I'm Jo Ashbourne, the Senior Tutor Academic Affairs and Programmes at St Cross College, and I'm very pleased to welcome you to the 11th Lorna Casselton Memorial Lecture. Both those of you here in person and also everyone who's online watching the live stream. This lecture series was established in 2014 in memory of Professor Lorna Casselton, an Honorary Fellow of St Cross College. Lorna was a renowned fungal geneticist and an enthusiastic promoter of science around the world in her role as the Foreign Secretary of the Royal Society. So being able to have a global audience online today is particularly fitting. The college is very proud to be able to hold this annual lecture to honour Lorna's memory. It's also nice to imagine that Lorna would have been thrilled by today's topic on the 10th anniversary of the lecture series. We're delighted to welcome Dr. Andrea Hinwood to give this year's lecture on the role of fungi in solving planetary crises. Andrea has been the Chief Scientist of the United Nations Environment Programme since 2021. She's a member of the Secretary General of the United Nations Science Advisory Board and is currently serving on several science advisory panels across the fields of environmental health, air pollution, and methane and modelling. Andrea was previously an Associate Professor at Edith Cowan University in Western Australia for 15 years and also held appointments as a Member and Deputy Chair of the Environmental Protection Authority of Western Australia and a sessional member of the State Administrative Tribunal of Western Australia. She served as the first Chief Environmental Scientist at the Environment Protection Authority in Victoria, Australia for 4 years from 2017 prior to becoming the Chief Scientist of UNEP. Andrea, we're very much looking forward to your lecture. Thank you.
So it's an absolute privilege to be here, and thank you very much for welcoming me and for particularly inviting me to come and give this lecture today. I'm very much in awe of what Lorna achieved over her career, and I cannot do justice in the presentation that I'm going to give you today. But I do want to start out by some general remarks, which I'll come back to at the end. The talk I'm going to give today is about environmental planetary crises, just the challenging situation that we find ourselves in, but importantly about science, innovation, and collaboration. And without the work of people like Lorna, some of the solutions that I'm going to talk about today simply would not be with us. And I guess my message at the beginning and at the end is that we have our future in our hands. We have phenomenal science coming out of a whole range of different disciplines. And as humans, we are innovative. Look at what we've managed to do to the planet thus far with all of the devices and the various activities we have. So if we have that innovative ability, we also can apply the same sorts of tools to solving the problems. So I have to confess, I'm going to depress you for a little bit. I'm really sorry, because I'm going to talk about some of these environmental challenges we're facing, and some of the statistics, you know, they're not terrific. But I also want to talk about some of the other things that are more positive, and importantly, how we can focus on some of these solutions. So I'm going to start by just telling you who UNEP is. Lots of people don't know who the United Nations Environment Programme is. We were established in 1972, and largely out of a lot of the work of scientists looking at the relationship between chemical exposures in agriculture and health. And our role, and still is to this day, is to set the agenda to promote implementation of the environmental dimension of the Sustainable Development, and now the Sustainable Development Goals. Importantly, we have a role in setting the environmental agenda and standards. We also have a role of keeping the environment under review. And one of the things that you'll see with UNEP reports and activities is we work across some 37 disciplines. We write about 32 topics because they're all related to the environment. And we are on an ongoing basis, looking at what is happening in the environment. One of the things that people don't realise is that we are actually governed, if you like, by 193 member states. What does that mean? Member states actually determine our agenda. So they come together once every couple of years and they put resolutions on the table. So where we have had successful government action in areas like ozone depletion, in areas of persistent organic pollutants, etc., that is because countries have come together in a multilateral setting and have agreed that these are significant issues that need to be sorted. And of course, that's underpinned by strong science. So one of the things that UNEP talks about is having a very strong and robust evidence base to do its work. So I'm going to talk about the state of the global environment, and for that I apologise. So I think this is probably of no surprise to this audience. We're using equivalent of 1.6 Earths to maintain our current way of life. That's in terms of energy use, production and consumption, the way we're actually using resources in the agricultural context, in the extraction of raw materials to make a whole range of products. 2% to 6% of biodiversity has been measured to be in decline across all assessed indicators for the last 30 to 50 years. Now that's only last year's statistic. This is the Intergovernmental Panel on Biodiversity, and they have a network of scientists who get together who actually produce these outcomes. But that's fairly significant because this is a global statistic. This is not necessarily just an individual country. And of course, we have 1 million of the world's estimated 8 million species of plants and animals at risk of extinction because of our activities. Now, at the same time, they're fairly stunning statistics, but countries also got together and they came up with the Aceh target, which is about the amount of land that is put into the conservation estate, i.e. that is then considered protected areas for biodiversity. And they set a target at 17%, which to me is a very low target, but we're nearly meeting it. Not only that, countries are now going ahead and they are restoring ecosystems, and they are starting to put land into protected area status so that we can maintain biodiversity. So 66% of the ocean is impacted by human activities, including fisheries and pollution, and in particular plastics. And 90% of the world's fish stocks are fully exploited. I've come from the African continent, and the information for the fisher people in Senegal is that they've basically lost their fisheries at this point in time. So they're sitting on their boats on the shore with no fish, which of course then has implications for the community as a food source, etc. But in August this year, plastics is a significant issue for biodiversity and for many areas around the world. And in August, countries are coming together to finalise a treaty to actually reduce plastic pollution, particularly in the marine environment. So again, this is negative, but there are positive signs on the horizon. We have to get them to agree, of course. 75% of the Earth's land surface has been altered by humans. I think we see this. And 85% of wetland areas. And of course, wetland areas are, again, amazing sources of biodiversity, but that provide ecosystem services and benefits for the whole community. In the part of the world where I come from, in Western Australia, the wetlands have been significantly removed through urban development. And as a result of that, it's actually acidified groundwater. And so there's a significant issue, as groundwater is probably one of the major sources of water in Western Australia, and it's becoming acidified, and of course that leaches metals out. So there are other implications of some of the changes that we're seeing, in particular these land use changes and wetland areas. And of course, you immediately go to migratory species who then have a reduced area in terms of their flyover areas, etc. And 50%, more than 50% of the population are living in areas which are experiencing the highest impacts from declines in biodiversity, water availability, quality, food security, and in terms of health risks. And of course, climate change, i.e. heat. So many people do not have access to cooling. Vast areas of the world still do not have appropriate levels of cooling in a warming world. And this is a significant issue, again, in terms of the health of populations in particular areas. not to mention that in terms of climate change and the impact on some of those populations that are experiencing more heat, but those that are experiencing more extreme events like floods, like landslides. In Uganda, the Ugandan government is already moving people out of particular areas that are very prone to landslips and landsliding because they can't rebuild them, because they know it's probably going to continue. And then economic activity, which is dependent on nature, which I think we probably understand quite well. The value is huge. There is a very, very strong interaction between nature and food, and we therefore need to, again, make sure that we maintain both the productivity of our land, but also biodiversity to protect land, water, and our species. And of course, 70% of the projected loss of terrestrial biodiversity is related to agricultural expansion. And in locations like Africa, Latin America, of course, there's a need to feed populations, and then there is tension with land use in those particular areas. So it will get better, I promise you. It does get better. And people ask me at this point, they say, so how can you still do the job you do? Because actually, I don't think I would be able to do this job if I didn't actually feel that we can turn some of these things around. And indeed, we are seeing positive change. So climate change, I've left here. 2024 was the warmest year on record. If I was here giving this talk next year, I'd probably say 2025 was the warmest year on record. And so this year's probably the coolest year for the next 10 years. The past 10 years, we saw the warmest individual years with an average of between 1.34 and 1.41 degrees above pre-industrial temperatures. Now, this is really important. Everyone talks about temperature increase. The Paris Agreement with climate change has an aspirational goal of not breaching 1.5 degrees above pre-industrial temperature levels. It's an average, it's not 1 year. So far, we're at about, I think someone did a recent estimate, I think it's something about 1.38 above pre-industrial temperature levels now. We have not breached that aspirational target, and I'm going to show you a graph which says that if we act very, very quickly in the next few years, and we do have solutions, we might be able to peg it at 1.5 degree temperature increase. That doesn't mean that we won't have some of the effects of climate change, but it does mean we're not going to make things a whole lot worse. With that being said, if we keep emitting at the rate we are, we'll still have a significant load, which is going to cause some problems. So we have increased greenhouse gas emissions, GHG, greenhouse gas emissions, surface temperatures, ocean heat, and acidification of the ocean, sea level rise, reduced Antarctic sea ice cover, and glacier retreat. And in fact, the glacier retreat is quite a significant issue, particularly in the Europe and Asia context, in terms of the amount of water that could actually end up coming off some of those areas. And there's an acceleration of the number, speed, and scale of climate records. And of course, we're seeing these extreme weather events occurring across the globe, and where millions of people are being displaced. And I'm not showing you some of those statistics, but something like 1 in every 69 people are being forced to migrate, either from extreme events, from conflict, either external conflict or internal conflict within particular countries. So that's a massive statistic. 1 in nearly every 70 people is having to move. UNEP puts out the emissions gap report every year. And this is where UNEP looks at the commitments that countries have made to decreasing greenhouse gas emissions. So they actually submit what is their plan for reducing greenhouse gas emissions. UNEP takes that and it says, okay, what's the gap? What do we actually have to do to make sure that we don't exceed this 1.5 degree temperature increase against pre-industrial levels? And so this is the report in 2023, broken record, because we're kind of saying much of the same things every year. And if you look at this particular graph, you can actually see with the current policy scenario in the blue line, we're not actually getting where we need to get to with the green band at the bottom. We need to be where the 1.5 degree range is. That's the gap that we're talking about between the current policy scenario and where we need to be. But I want to come back to it because it's not all negative. And this is where we're going. We've got these things called short-lived climate pollutants. And the short-lived climate pollutants, they don't stay as long in the atmosphere. And they're black carbon, methane in particular, tropospheric ozone, and hydrofluorocarbons. So you'll remember when we had ozone depletion, they were caused by chlorofluorocarbons, and these hydrofluorocarbons, they depleted ozone. Well, some of them are also greenhouse gases, and very potent greenhouse gases. And one of them in particular is methane. So methane is produced from agriculture, from landfills, waste areas, and also the oil and gas industry. This is just a graph of methane concentrations. Why? We're using a lot of fossil fuels. We've got a lot of uncontrolled emissions from the oil and gas sector. And this is the global monthly mean of methane, and it is increasing. And it's not slowing. However, one of the things that is positive about methane is it's a short-lived climate pollutant. There are solutions available already to actually reduce methane, and industries have actually joined the International Methane Observatory, where they're having their facility emissions measured, and they are starting to cap the sources. Why is this important? If you actually significantly reduce a short-lived climate pollutant and basically take it from being emitted, you can save a 0.3 of a temperature increase. So if those sectors across agriculture, across waste, across oil and gas industry, and some of the big industries already start to cap those sources, we buy ourselves a little bit more time in terms of that temperature increase. And I know it sounds a very, very small amount, but actually at this point in time, 0.1, 0.2 of a degree probably matters. So there are solutions. The other thing is there are alternatives to some of the chlorofluorocarbons that are used in the refrigeration and cooling sector. If they were also rapidly phased out over the next 4 or 5 years, it also has a similar effect. And the benefit of that, it also then provides some cooling for those people that currently are suffering from heat, etc. So there are options, and this is what I mean. Yes, we still have time. And this is really hard message to put across at this point in time, because people are going, oh, well, we haven't seen any action. And so, Andrea, you've got your rose-coloured glasses on, and that, we're not going to get anywhere. But actually, we are seeing some signs in industry, and look at the renewable energy sector. Look at the massive increase and uptake in electric vehicles. And they come with some intended issues as well. But there is actually some movement, and we are starting to see some regions of the world. Others have taken a different stance, but we won't talk about that tonight unless we have to. But, what I can tell you is from our 193 member states, in all of the regional consultations that we've been having in the last couple of weeks, even though there are a couple of countries that are kind of going backwards, most of them are still staying on that agenda to reduce greenhouse gas emissions, to actually restore ecosystems, to reduce pollution and waste. So, and we probably have another 4 or 5 years before I will say, okay, it's too late. But at the moment, it's okay. So I just wanted to round it off in terms of pollution and waste, because we talk about triple planetary crises in relation to environment. That's the crisis of climate change, the crisis of biodiversity and nature loss, and land degradation. but also pollution and waste. 94% of the global population are exposed to PM 2.5 levels, with an estimated 7 million deaths a year. More recent statistics put that about 8.4 million deaths a year. Most of that is occurring in the Asia-Pacific area. And without policy intervention, one of the things that people don't realise is when you add heat plus air pollution, PM 2.5 in particular, equals more health impact, because you actually then make more aerosols. So again, we've got all of these co-benefits of actually taking action to address the environmental problems that we have. I just wanted to show you this. This was a report that was released last year. This was a report that was done out of my office, where we undertook a horizon scanning and a foresight exercise. We actually surveyed thousands of people across the world. We asked for what the issues, we gathered information. And one of the things that we did find from this report is that there certainly is a changing relationship between environment and health, and that traditionally these two silos are considered separately. But we looked at the great acceleration and actually added some more data to it. And if you look at it, it's all about consumption of and production and consumption of resources relating to adverse health effects. So we think that perhaps the other thing is to focus on the health of populations, both with respect to frequency and intensity of events like heat, but also pollution across the globe as well, which is almost like, other than air pollution, is an invisible component of the environmental problem. And we do think that these interrelated issues need to be tackled in an interrelated way as well. So what are the solutions? I've talked about some of the other solutions, so now I'm getting on to all of your favourite topic. And again, another confession. My interest in fungi at the start, when I was studying, was as food, because I like my food and I like my mushrooms, and science fiction, because I really liked some of the science fiction stories of all the spores that you would see in, and those of you that are not interested in that genre, I'd recommend that you start having a look at it, because it's hilarious in terms of what happens in space with spores, what happens to the individuals, and they change different, they become different entities, they're not human anymore. So that was my great interest. But as you'll see, I hope, in the next few slides, that fungi offer an enormous number of solutions to some of the issues, and particularly in terms of reducing greenhouse gas emissions, reducing impacts on biodiversity and pollution and waste. So what are they? I think this audience knows this better than me. I know there are a number of experts who I'm going to refer any questions to you. So there's an estimated 1 million species. I know I've seen the figure of 144,000, but people are saying that there are probably many more, and there could be 1 million, and that includes your mushrooms, molds, etc. They're not plants, but they have cell walls, no chlorophyll, i.e. they can grow underground. And they grow by digesting and absorbing organic matter, and they have these things called mycelia, which is really interesting for me, because this is where the science fiction comes in, and also maybe some of these products are a bit out there as well. And mycelium combined with materials, seeds and other substances to create biodegradable products. So you heard me talk about plastics before. Plastics are considered persistent pollutants. Why? When they find their way into the environment, they take a long time to break down. And in the breakdown process, they become macro materials, then they become micro plastics, then they become nanoplastics, right? And that, depending on the environment they're in, can take a very long period of time. Of course, an organic substance will take a much shorter period of time. That's not to say it still needs the right conditions for that to occur, but it probably is a better option. And one of the things I'd like to ask this audience when we start to look at some of these options available is, for functionality of some of the alternative products that we can make, do we need to actually add some of the chemicals that are used in plastics? Because there's some debate about that. So what's their role? They're key decomposers in ecosystems. They break down organic matter. They recycle nutrients, i.e. they make our soil healthy. They digest and absorb nutrients, through their dense network of mycelia. And of course, this supports soil health, nutrient cycling, and ecosystem stability. One of the things about ecosystems is we need all of the diversity, and that includes our fungi, our bacteria, our different plants, animals, etc. And they offer a nature-based solution to global environmental challenges because they might help us sequester more carbon. That is important at this point in time. If we want to take carbon out of the atmosphere as we're still emitting, maybe some of these solutions which improve soil health and then improve our ability to sequester carbon and breaking down pollutants such as plastics, which I'll talk about in a moment, and also helping with biodiversity. I'm already a fan, I already was when it came to food, right? So there are many applications and benefits. Soil health. Alternative proteins. You're probably aware that in terms of, there is a very strong view that we need to be reducing our consumption of meat because of the amount of land that is used, the amount of water, and it's degrading ecosystems as well. And one of the alternatives is that fungi could actually provide and be an alternative meat or protein, which we can actually talk about. Climate cycling and regulation, the breakdown of plastics, the breakdown of other wastes. I know there have been some trials in terms of mining wastes. The thing about metals, though, is they kind of just cycle in the environment. Even if you take them out of one bit, they'll end up somewhere else. To make new materials, fire retardant products, panelling, foams, paper. I talked about carbon sequestration. I'm not going to talk a lot about their medicinal uses, but of course they have applications for pharmaceuticals and medicines and bioremediation, as I said, in terms of some particular types of waste. So, as I said before, they can improve soil health. And this is really important, both in terms of maintaining the nutrients within the soil, which we desperately need, particularly in those countries where that's been degraded over a long period of time, but also to improve carbon storage. Now, I'm not going to tell you that at the moment we have great science in terms of how soils are taking up carbon, but there are lots of researchers who are actually doing work in that space, and it's a very, very exciting area because when we actually have some information on that, we're going to be able to talk about what sorts of solutions are available for governments to be able to put in place. Can it degrade plastic and other waste? So this is this is the Kew Gardens who said this. The first ever State of the World fungi produced by Kew Gardens and a team of 100 scientists, saying that it degraded polyurethane in a matter of weeks. So this is where it breaks the polymer bonds in several weeks, offering a faster plastic degradation in the environment. And it can be genetically altered, which comes back to Lorna Casselton, in terms of the production of an enzyme which digests plastics. So these are really innovative. Why? We produce 400 million tonnes of plastic waste every year. A lot of that is in landfills. That's okay. That's still an issue. We can talk about that later. But a lot of it ends up in the environment. So if you are able to have something that is going to degrade faster and reduce your potential impacts, then perhaps this is a solution. Or maybe a better solution is being able to have your waste management practices, but having a very effective way of actually breaking down your plastic waste, which even in a landfill can last a very long period of time. I first came across this as a fire retardant because I was in Victoria for a number of years, and my colleagues at RMIT were actually starting to experiment using fungi as a fire retardant. And they were actually looking at through chemical modification, but I've also seen some literature where they've actually started to add things like glass shards and things like that. And when exposed to heat, the mycelium forms a protective char layer that insulates underlying materials. And I think we've all seen on the news the horrific circumstances when a fire occurs in a big building that's got some of this unfortunate cladding. And a lot of the plastic-based cladding produces toxic fumes when it burns, and of course it is highly flammable and it takes everything else with it. So this work, in terms of application as a fire retardant, is also extending to other areas now. And it's something that may change the nature of some of our building and construction materials in the future. It's pretty exciting, isn't it? See, this is science, innovation, nature. It's a great combination. Leather substitutes have been around for a long time. And this just shows how fungi grown in 28 days, it's harvested and then it's dried. And it produces a material which feels like leather. It does feel like leather. And there is also a suggestion that it might actually start to be able to be used in the fashion industry as a new material to wear instead of plastics, because plastics are really problematic in terms of the environment. So maybe we have some solutions here that we might be able to put in place. We still need to manage our waste. We still need to look at consumption and production, but these might be some very positive alternatives for the future. And then as foams, flooring insulation, and paper. So this is where you bind agricultural byproducts. So you're taking an agricultural waste into a biodegradable and carbon neutral foam, because you're actually locking up some of that material within the foam. In insulation and flooring and panelling, I don't know if any of you have renovated recently, but my goodness, there's a lot of plastics and materials used in that particular sector in our homes. And I think I would be a lot more comfortable if I actually had a biodegradable product that would last a long time, but then at end of life is not going to create so many issues. For domestic products such as facial foam cleaners, shoe insoles, that sort of thing, and of course into paper sheets. And it's being researched, as I said before, in its application in construction and building. As 3D printed materials and batteries, this really stunned me, I have to say. So I was a bit floored when I read this one. I thought, and I hope there is someone, if someone in the audience has actually been researching this, I'd really like you to put your hand up and tell us a bit more about it, because this gets into my science fiction interest, that you can actually have a species that can be 3D printed in the first place is pretty amazing. The fungi grow in the inks, but they're used as electrodes. They can pass electricity, and they've created these fungal batteries that at the moment are really limited, right? Apparently, they work for a few days with just sensors. They can't be used for anything substantive. But if you look at this, to me, this is incredibly innovative. Who would have actually thought? I wouldn't have thought about that. Maybe you would have. But to me, this is quite amazing. So you've got microbial fuel cells. At the moment, they're really limited batteries. They can't be used. They're not scalable. But they can be constructed as also being biodegradable. Who knows where this is going to go? But I know one of the biggest issues in terms of our electrification of our world, and particularly of our vehicles, is we've got a whole lot of batteries. We don't recycle them. We don't know how to at the moment. So they're just sitting and being stored. So imagine if we change that dynamic and we do have something that can break down, that can be turned into something that is less hazardous. Because if you think about the composition of an electric battery, if we can recycle it and reuse it, okay, terrific. But at the moment, we're not quite at that space. And as I said, it can be made into other food types. So it's been used for hundreds of years, and it's been used in vinegar, in fermented foods and drinks, beer, wine, bread. Told you, I like food. Corn, for example, I don't know, I have tried corn. I didn't realise it was made from fungi, and I quite like it. I think it's quite a good alternative. And of course, this aspect of turning it into alternative proteins. And then we have the technologies to specifically address the environmental challenges. And I do want to make it clear, I liked this photo because it was fungi on a beach. They're not the ones that actually will be used for the development of biofuels or insulation, etc. I just like the picture. So this is really important. Aviation is a significant sector with a significant use of fossil fuels. And again, the aviation sector and researchers are starting to look at alternative biofuels. And one of the issues that are coming down the road for us is actually the use of fuels, of course, with the thousands of rockets that are going up to deploy, explore, etc. Well, they're all looking at alternative fuels as well. And maybe, just maybe, fungi might be something in the future that is more routinely used. Again, the development of insulation and adaptive building applications, and robotics and electrical products. So I think you can see that there is a huge range of activity in terms of potential applications of fungi, which not only start to reduce our use of greenhouse gas emissions, they reduce the persistence of things like plastic in the environment. I hope they would reduce harmful chemical additives that we actually put in plastics. Sometimes to make products functional, you need to use particular chemicals to make them functional. Maybe they will need to be added to these sorts of applications. I don't know. That's a question for some of the researchers who might be able to answer that on our behalf. But they certainly can make some significant improvements in the current products and landscape that we have. And of course, the importance in terms of protection of biodiversity and nature, because in their own right, they're beautiful and they're fascinating to look at, aren't they? The range and the variety of them. And in terms of biodiversity, it's incredibly important. So why are they so versatile? Because they contain chitin, the same material which is found in the exoskeletons of crabs and insects. It's a fibrous structure. It's similar to cellulose in wood, and it means they can be made into these easy-to-make products. When stretched, they're stronger than many plastics. And I think for those of you that have actually felt them, that they are. And they feel good. They feel like leather. It's quite nice. And they're not much weaker than some other products. So if you're actually looking at using them as a fire retardant and you need strength and flexibility and all those sorts of things, they kind of might be ideal types of products. But we're still at an experimental stage. The structure contributes to mycoprotein, making it like meat. That's why it's being used as an alternative or a potential alternative to meat, because of the texture. One of the things they've had with growing, they've got a whole range of research in growing different cells to grow meat, but they are having issues with texture. But there's a view that maybe because of the mycelia that they will actually have that texture. And of course, fungal paper strength can be substituted for specific flexibility, and the paper's transparency can be customised as well. So there are a lot of opportunities here. So what are my main takeaways from this particular lecture today? As I said at the start, humans are innovative. We really are. As I say, I just look at everything in this room. We are actually quite remarkable in our ability to innovate, to make things, to have ideas, to pursue them. Fungi are really good for the environment in terms of soil health, in terms of agriculture, in terms of biodiversity and health, because they're a good food source. We have a large range of sustainable solutions which need scaling. So one of the issues here is most of this is science. There are some processes that are development stage, but they're not currently scalable. And these are the things that perhaps need to be looked at now. How do we provide the funding to do the appropriate trials that enable these things to be scaled and then taken up by consumers to improve? And it's my contention that we have the solutions at hand across a whole range of areas. Will fungi solve the climate crisis? No, we still have to reduce greenhouse gases. But if we start to use it to make alternative fuels that get picked up by other groups, we actually add, and all of these types of actions come together to actually solve a problem. There won't be one solution. There will be a multiple across different areas. And the only thing I would say is one of the things that we really need to start doing is to consider these types of issues in an integrated way. At the moment, we talk about biodiversity, we talk about climate, we talk about pollution. We actually need to bring them together and to bring the economics and societal aspects to actually solve these problems. We do have the ability to do this. There are lots of good examples. And with that, I'll thank you very much for your attention. Thanks. Any questions?
Is this going to... it's probably going to sound silly, but you talked about the ability to reduce methane.
Yes.
But how do you cope with the methane that is produced by cows and other animals?
Yeah, so there is a lot of research going on in agriculture at the moment to provide different feeds. And indeed, there's a research, the Livestock Research Institute in Nairobi, where I live. And they're having phenomenal success with cattle in particular, but also other animals, with reducing their methane emissions. The easiest though, so there's about 30% from oil and gas, maybe a bit more, about 30% from agriculture, which is not just animals, it's also from your rice paddies and all the other areas, and then you've got your other 30% or thereabouts from waste, and we've got some other bits and pieces. So if you actually then focus some of these changes in feed, that you actually, they've done some really nice work in the rice paddies in Asia in particular to reduce methane coming from those areas. And you take the 30%. If we just reduced 30% of methane across those areas, we have that temperature saving. So this is where we really need to start getting the scaling of those sorts of activities, and we need industry to come on board because, of course, in the oil and gas industry and in the waste sector from our landfills. And there's been some interesting work. When we have our oil and gas platforms out at sea, in the past, we just let them go. We haven't checked all the flanges that are actually releasing methane. And they've done some really nice work now to observe where the methane's coming from, and you can then go back in and stop the source. So I think that in the next few years, with Will, and from what I've seen of the interest in industry, etc., and in the agricultural sector to actually look at these issues and take it seriously, I think you're not going to completely stop it. Of course not. Methane's also a natural pollutant. You can't treat it in the same way. You're always going to have some level, but you can make a substantive difference. Thank you. Yes.
Thank you. When I think of wood as a really solid stuff like this, and I think of fungi, all the ones that I know are sort of slippery and slimy and got no strength at all. What processes, or are there fungi that I don't know about that are more solid, or is it processes to make them
It's
into
their
more
functional
solid?
characteristics of the mycelia that can be pulled together, and we do have a couple of researchers who can actually answer that question as to how they are made. But my understanding of the RMIT researchers, and you can clarify this, is that they actually grow them in sheets that they can then pull out. So they're not becoming the mushrooms or the fruiting bodies, they're actually taking the mycelia and they're forming into these layers. Yes. Do you want to just quickly answer that? Sorry, I have some colleagues in the audience who can answer these questions for me. So,
So, for example, to create this type of materials like leather, what you have is you have a base of a substrate that could be like agricultural waste or chips of wood, and then you provide the right conditions for the fungi to grow. But then obviously you don't let them to, so there are some species of fungi that don't produce fruiting bodies, that, and we use some of those or the others. But anyway, at the end what happens is that you can have the mycelium that keeps growing. It creates like a thick layer of fungus on top of those materials where they are feeding from. And then you can cut the layer, harvest it, and then obviously before you can compress it, and then there is then cold presses, hot presses. You can mix some other natural compounds, and you can change the characteristics of that mat of fungus.
And so can I ask a follow-up question? Given I'm giving the lecture, but this is the beauty of having scientists around. But my interest in the functionality is the additive component. In order to make some of these products, you still might need to add particular chemicals. That's right, isn't it? Yes.
That's true. So, for example, what happened?
Yeah.
No, you continue.
So, for example, let's put the example of the fungal leather that you put. So that exists already in some fashion brands are already doing. They call it vegan leather, and obviously, what you need to add some plasticizers or some components that will change, for example, the tensile strength of that of the fungi, because otherwise it's too weak and not flexible enough for acting as a leather. But then you need to add some chemicals. You want to add something?
Yeah, that's a lot of possibilities here to engineer and improve the property of fungal material. For example, fungi themselves, they produce a very powerful surfactant proteins, the proteins that have very strong surface activity. These proteins, they're able to assemble on hydrophobic surfaces, making them more hydrophilic, and vice versa. So by manipulating in engineering, genetically engineering fungi that are used for production of this fungal leather, or producing these enzymes, these proteins, and adding them in fungal leather, we can actually add to stretch, to elasticity, to water repellency, and so that it's just a starting point. But here there is a really, the door is open for the technology.
Yeah, thank you. And I think that's its benefit. There are a lot of potential applications. I'm still blown away with the electrodes. I thought that was quite unique. If anyone's got any knowledge on that, I'd be pleased. Yeah?
Sorry, can I ask a question? Thanks
Sure.
for the amazing talk. It just occurs to me, I'm amazed by the idea you're using the fungi to 3D printing, and they're going to be a battery, and they're going to be a power source. And
Yeah.
then it just occurs to me,
Science fiction.
like before I'm going to be throughout the room, but I think few years ago, there was a wave of like crop going to be used as a power source. Crop is amazing, crop is good for the agriculture, it's good for the environment.
And
good
it's not
for
happening.
health. It's not happening.
No.
So fungi is it's compared with other or the kind of solutions is already kind of its ultimate good one compared to the other ones.
So this is where the challenge is, because at the moment this is in the science space. This is not, I mean, apart from food, like, you know, i.e. actually having mushrooms as food, in terms of actually scaling this, that is where the tension is. And that is similar to other new alternative technologies. Why? It's cheaper to just extract the resources from holes in the ground, or you've got an existing oil and gas industry. So if you are already, that it's not cheaper from an environmental point of view, but if it's cheaper, why are you going to go and fund and invest in some of these alternatives? Look how long solar energy has actually taken to really take off. It's been around for 30 years. And it's just that time lag. Now it is starting to absolutely take off, where you've now got many solar cells in particular area. So the one thing I do think we need to do is work out how we can actually help scale innovations. Not all of them are going to work, Some of them will fail, but at least to actually invest in some of the science where there is, solid information about the processes, what the environmental impacts are, etc. And my issue from the environmental point of view is that we don't have a regrettable substitute, that if you do produce something else, that you have adequately considered the various aspects of it, so you don't actually introduce a new problem to one that you've already got. Thank you for the question.
Hi. So obviously all of these fungal solutions are really interesting and have a lot of potential, but you did give the kind of 5-year cap on when all this needs to happen. Do you feel that it's scalable to a large enough scale to have enough impact in 5 years? Obviously you need the combination
So fungi are not
of other
going to
solutions.
solve the reduction in greenhouse gases in a 5-year time frame. But addressing methane, scaling some of these other solutions, restoring ecosystems, making sure that you have alternatives to particular cooling applications, etc. If you actually do those in concert and not expect one to outweigh another, then you're actually going to make a dent. But what you're also doing is you're making a dent for the future because you're not producing products that have the same intendant problems. But that's also the trick, is making sure that you don't do something that you have considered the waste. So the end of the product's life, if you have added a chemical to it, how will that be dealt with? Is that able to be chewed up by bacteria, for example? I don't know. Whatever might be the particular solution. So we need to do a range of different things. And I think the other trick with all of this is, it's really hard for people, and I know industry has said to me, but Andrea, what do we do first? Well, you do what's sensible for you to do first. You do the energy efficiency first. You make sure that all of your activities, then you say, right, I'm going to cap methane. Then I'm going to start using some of these alternative products. I'm going to invest in this because actually I think this is going to work. So I think that as we start to we've got to be realistic. We're not going to turn this around yesterday. But we have a window now. And I think, as long as we can keep the geopolitics at a nice level, we'll be doing pretty well, I think. Yeah.
Thank you.
Sorry, the lady behind there, then there, then.
Hello. Can fungi grown on disgusting things be edible?
Probably not. Absolutely not.
Absolutely right.
No. So if it is being used to chew up waste, I haven't done the studies, but I would hazard a guess, no, because you're actually using it to destroy something. And I think the thing that's interesting, if you're using it with a plastic is comprised of a whole range of chemicals, some of which are also persistent. So as a plastic breaks down in the environment, some of those additives find their way in the environment. If you've got a fungi, maybe it will break down some of those persistent, but it probably won't. It might take out the metals, but you're going to have to then manage that. So that's why we have to think about the regrettable substitution aspect of everything that we do. And I guess I would like, and okay, I'm an advocate for the environment, of course, but I would like us to think about the environmental implications of our action before we do that. So we say, okay, instead of a plastic straw, I'll have a paper straw, but do we need a paper straw? Do we? No, probably not. So, it's that, anyway, I could talk about it there, and there. Yes.
Hi. I'd like to ask you about the dark side of fungi, which is the...
because the death and mayhem.
Well, there are a lot of scientists who are worried about what could be uncontrollable spread of fungal infections affecting food sources, food crops, and even human health. And I focus on Africa. I'm just curious, so Africa has huge needs for systems, for water and sanitation and all that. What would you recommend? What are the state-of-the-art approaches today on how you can protect food security and also human health against uncontrolled fungal infections?
Yeah, so the regulatory regime is in developed countries, not developing, clearly. And so the examples in countries like my home, Australia, Europe, America, we probably have the best controls. And not only that, you're absolutely right, which is regrettable substitution, that we don't actually create spores. We don't have a whole lot of, I don't know, cryptococcus or something like that, which ends up, you know, impacting the health of populations because we've not understood it well enough and we've not managed it in terms of the research we do, i.e. the biosafety level when we're actually doing research when we do have the potential for airborne spores, etc. It's a really, really good question. And I think, but I guess the other thing is, when you look at synthetic biology, generally, the developments in that space are massive. And one of the challenges that we have in the UN system, and I'm working with my colleagues at the World Health Organization, Food and Agriculture Organization, and the Animal Health Group on dual-use research, because, of course, the other risk with some of this experimentation is the potential for these to be used for the dark side, if you like that. But again, it gets back to then how you manage it, how you identify it, and I don't think that means you don't do it. You actually understand what you're working with. That's where the science comes in, and as I say, in terms of this memorial lecture, that's what Lorna Casselton, you know, in terms of understanding, has created. So I think that's where science, innovation, with some controls is really good. But yeah, you're right, in developing countries, the regulatory regimes are not there, the biosafety is not there. Yeah, good question, thank you. Sorry, yes.
I was expecting you to speak a little bit about the importance of fungi in maintaining
in terms of soil health, yeah.
Soil health, and particularly arbuscular mycorrhizal fungi, because they not only have the sort of metabolism which will help to remediate nitrogen-sick soil, but they also can have potential effects upon whole soil structure and consequently upon all the little habitats within the soil that allow soil biodiversity and soil health. So I would have expected arbuscular mycorrhizal fungi to be sort of your favourite thing.
Well, they're all important, and particularly in terms of habitability and soil health in relation to habitability and areas to actually maintain. So it is absolutely a fundamental. I guess I got interested in all of the other applications that people don't know so much about. But you're absolutely right, absolutely fundamental and really important to understand. But we also need to maintain our environments, and then we need to restore them. And so then the interesting bit for me is this question, and I had a great discussion earlier about how do we restore ecosystems and put fungi back. I don't know the answer to that. Is that something that we can do?
Well, I think if it were me, I would want to look at all the range of metabolic things that fungi can offer you. They can undo the damage done by harbour to a certain extent, because we have too much bioreactive nitrogen, but through having taken nitrogen which is stable in the atmosphere, it's in all little pairs, you know, inert, and smash it up and make it into readily usable nitrate in an agricultural fertilizer. Fungi do the opposite.
Yes, that's right.
They've got the ability to reduce nitrate and turn it back into protein. And so that can have structural implications for soil.
Yeah, I should have. Thank you.
And for rivers, as well.
Yeah, of course. There you go. I'll add that to my list. Thank you. No, thank you. No, thank you.
Yes, good evening. Going back to older times, the birch polypore was known as razor sharp, so it's a possible abrasive. And King Alfred cakes, a potential firelighter. You know, those are two possible applications. But coming up to more modern times, plants and trees and so forth are meant to be able to communicate via fungi with each other. And I wonder if there's any application in using fungi in conductors and improving communications. Has anything been looked at in that field?
I have no idea. Not that I've seen, But that doesn't mean that there's not an application. There's not an application there. So yeah, sorry. Oh, you know there's an application? No. Oh, different question. Okay, here and then here. Yeah.
So you mentioned that the fungi can be used in 3D printing for batteries. Do you think that because lithium-ion batteries, they're quite a big they contribute quite a lot to carbon emissions, the production of lithium? Do you think that 3D printed fungi batteries, do you think they're a viable alternative?
I don't know. I don't think we know enough yet, and I think this is where we really need to start doing these comparative assessments of what we have and what the alternative looks like. Because maybe, and I simply don't know the answer to the question, is that maybe you need more energy to produce some of these things. You've got to get your energy from somewhere. So it might be better in terms of operating as a small battery or something like that, and it might improve your end of life. But then you have to consider, will it be better to be able to extract all the rare earths and metals from your battery and reuse it over and over and over again than producing something else? I think this is where we need to start considering this concept of regrettable substitutes, and that we actually seriously take into account the life cycle of the product at whatever the resources are that go into it during its manufacture, its use, and then end of life. And I think if we start applying that, whereas what we currently seem to be doing is that we think, oh, this, and you heard me, you get excited, you think, oh, look at this. And it is exciting, it's terrific. But I think we need to kind of stop and say, okay, let's actually do this methodically so that we're doing those comparisons so we actually know this is better. And we recently put out a report on what do you call them? Novel meat alternatives, which includes, cultivating cells, using soy for different products. In my view, the jury is still out as to whether some of those meat alternatives are going to have the benefits that we think they do. They may well, but the evidence in terms of improved health, because you want to make sure you've got the appropriate nutrients for a human, whether we are pretty confident that they will be less greenhouse gas emitting and they will use less water. But we don't know about some of those aspects in terms of subsequent pollution, biofilms, the other aspects of it. This is why we need to be considering those environmental aspects seriously, so we do something cool, not something that's going to have greater problems or have the dark side spores that are going to, turn us into other species. I don't know. Thank you for the question. Just here.
Probably a hard question.
Oh, okay.
Thank you very much for your lecture. And we mycologists, we frequently have this moment when we impress the audience because it's quite easy to find that the people don't know much about these amazing applications of fungi. So how do you explain fungal blindness, and what can we do about this?
Yeah, I don't think it's just related to fungi either. I think it's a blindness to connect with nature and biodiversity, and therefore what's going on around you. And so I think that there is something about how we better connect with our surrounding environment and realise the benefits that it has for us, and that we are part of the environment. And a lot of, again, it is very difficult because let's take the example of a coastal area, and it's natural and you love to walk along it, but people want a restaurant to go to, so they want to put the restaurant in the coastal area, which affects the coastal processes. It's actually the same thing when you go into a forest and you want to put infrastructure in there for trail bike riders or whatever else. So to me, it is a really important question, and I think this is where science communication comes in too, in that we as scientists, and believe me, I've had epic fails in communicating environment and science to bankers. That was only a couple of weeks ago. I hope they're not listening. I didn't cover myself in glory in the way that I was communicating. And I think actually that is our responsibility as scientists, to actually work out how to communicate for a particular audience and get that excitement that you see with that. But also it's also a privilege to be a scientist and to be a researcher. So what comes with that privilege is that you make sure that you do your job and you do consider the range of issues, or you work with people who can provide those other disciplines to answer those core questions.
We, as mycologists, we try to implement or advertise the use of term funga similar in a similar way as flora and fauna. So funga as the totality of fungi in a certain region or in a habitat. So can United Nations do something about this?
I was actually just about to say that. I said that's where organisations like UNEP do come in, because they do have the ability to actually provide that information across member states and across stakeholders, and to actually educate in terms of the significance of fungi in the environment, in biodiversity, but also to make them fun. I think that, I mean, they're quite beautiful, aren't they? So I think maybe the more people get exposed to them and consider them, then perhaps we'll be in a different space. Okay, I think we're probably, one more here. Okay, 1, 2, and then that's it. 3, okay. And if I can't answer the question, I've got my experts.
Mine is not a question. As a final tribute to Lorna, she worked on the pheromones on coprinus, and she showed us how intelligent fungi are, talking to each other. And I think that tells us fungi are very important.
Thank you, thank you. Where was the person? Up there.
Thank you for tonight, firstly. I've just started researching on looking at taking in atmospheric CO2 and trying to convert it into calcium carbonate via fungi. But thus far, I've kind of gained the idea that it's being spoken a lot about within the scientific community, but not necessarily within organizations and within industry. So I would have 2 questions, which would be, is anybody talking about it from your experience? And if they are, is it being spoken about as a big solution or an interesting solution? And then the second would be, what would need to be addressed around that situation to make it plausible to then take on?
If you have solid evidence that works and is scalable, then people will take that forward. If the research is at a point where there isn't a coherence and consensus around whether that's enough and where that can be applied, it won't be taken up. So I can tell you from my organisation's point of view, there are all sorts of things that are put forward. But if there's one study that says that, I don't know, I'm trying to think of a different topic so I don't say something that's not good. But just one study that is suggestive because of the way the study was done, we can't use it because you need to have that weight of evidence to enable you to then work with governments in terms of their negotiation over key issues. So I would then say, from the research community point of view, this is where the opportunity is to get that consolidation, that weight of evidence where you're pretty sure that that's actually going to work, then we will use it, absolutely. And there are a number of technologies in that basket where you're still going, not sure yet. Yeah.
If it was ever proven to be scalable, at least in one environment, say a singular entity, a singular industry, rather corporation managed to achieve it, would that be feasible, or would it need to be scalable by different countries, different organizations, by the masses, or would that one entity be sufficient?
That one entity would be sufficient, as long as you had the parameters around why it is successful in that entity.
Okay.
Because what we try to do is to provide solutions. Part of our role is to provide solutions for member states on a whole range of issues. So what you don't want to be doing is putting that out and say it works in this industry, but someone from a particular government may not realise that this other industry is completely different with completely different parameters. So again, it's about how you would communicate that and how you would make sure that the evidence base is well understood, that you're not misrepresenting. Yeah.
Thank you.
Yeah, no problem. Gentleman here was next. Oh, sorry. Okay.
Thanks very much indeed, and thank you. Yes, a captivating presentation. Thank you very much. I work in disarmament in Geneva.
Oh, okay.
And,
I'm coming to Geneva next week,
I think
but not disarmament.
Other crises being what they are, I think someone mentioned the word geopolitics, which spurred my mind. I mean, are there applications, it's perhaps more for the front row brain trust that we have in the room, in dealing with unexploded ordnance, dealing with mines in fields, and either as a marker or degrading the explosives so that they're less harmful for populations? The other question I had was, you mentioned consumption of mushrooms from a food perspective, but consumption of mushrooms from a cognitive perspective. My background is also in behavioral neuroscience. And the climate crisis being what it is, I think it seems that a lot of young people are paralyzed by the overwhelming nature of how this is all pervasive. I was just wondering if there was any research perhaps being done.
Actually, there is.
In that area.
Yeah, I'll take the second one first. Actually, there is some nice research being done in terms of the anxiety of people about the environmental crises that we're facing. And the solution that has been put forward that appears to work is to be actively engaged, to actually do something positive, so that if you, and this is, you know, people say, well, I can't, what do I do? There's so many things to do. Just do one. You don't have to do everything. Do something that you really feel passionate about, that you can do something about. That is probably more. And, you know, in an ideal world, people would be living as sustainably as they can to actually learn. But that's what we've found, particularly in terms of climate anxiety, that apparently that appears to be working with people who feel like they can't move. I think the other thing on that, though, is that, and this is, I actually blame myself and my colleagues in the environment movement, because I think what we've done is we've talked about gloom and doom, that everyone's going, it's all too hard, I can't do anything. That's actually not that's not right. There's a lot we can do, and I would encourage people who feel like that to be actively engaged, and even if they're a finance person, start to look at finance in respect to some of these innovative technologies that we need to do some experimentation with to actually sort out. Now, on the first question in terms of bombs and disarming bombs, there's a lot of work out there, isn't there, at the moment? I don't know the answer to that question. Is there any ability? I have not seen anything in the literature, but then I may not have. Is there any literature available on helping that aspect? Unexploded ordnance, or actually even indeed the chemicals associated with munitions. UNEP has done some work in Ukraine and Gaza in terms of the chemical composition of some of the equipment that's being used, which of course then stay in the environment and depending on the geological conditions can migrate. So if you could use fungi with those types of chemicals, that would be a great solution. I don't know. Nice one. Why don't you do some work on that? Okay, thank you. Okay, last question from this gentleman here. Yeah, I hope it's an easy one.
It's great to hear great things about fungi, but I do global health, so I know fungi also causes lots of problems. You have lots of fungal diseases, lots of food is destroyed by fungus. So actually, I was trying to twist the question around, and is there ways of dealing with problem fungi that could also solve problems? For example, if we could create less destruction of food crops because of bad fungi, that would actually have lots and lots of ripple out effects in Africa in terms of climate change and reducing energy consumption and so on and so forth.
Absolutely. And in fact, some of my colleagues who work in this space are doing a lot of research to try to actually stop that from occurring and working across developing countries. I think that's about information sharing, technology exchange, etc., because I think those countries that have got very good measures in place to reduce those hazards, they can actually share that with the developing world. And the developing world is you know, they're ripe for it. Yeah.
Can you use good fungi to destroy bad fungi? I mean, I'm not an expert
I
on
can't
that.
see why not.
Yeah,
I can't see why not.
Thank you.
I mean, you know, from a chemical background, you could just add chemicals. Sorry. No, I'm joking. Sorry, go. You can answer that. Good bacteria eating bad bacteria.
Thank you.
Andrea, thank you very much. We've kept the questions going almost to the end because you've stimulated such a lot of interest. My name's Kate Maver. I'm the Master of St. Cross College, and we're absolutely delighted to have this memorial lecture for Lorna Casselton every year, a great fellow of St. Cross, and I know there's several people in the room here who still remember and cherish Lorna's work. I was struck particularly by what you were saying about how important it is to bring together all the different disciplines to work together on this kind of problem and opportunity. And certainly, I know at the moment, Oxford University has got a number of initiatives to bring people together, not least the Oxford Earth programme, which our current fellows I know are leading and working on, bringing the different disciplines together, cross-fertilisation of ideas, innovation solutions. So very much in the spirit of what you've presented today. Thank you for opening our eyes to all the things that are already happening, stimulating our thoughts, challenging those people in the room to come up with the solutions we haven't yet. And thank you particularly for being so hopeful and optimistic about the...
I have children.
that we can do something and will. And I would like to say that I think you are an excellent communicator, and you keep saying we're not doing enough. You're doing lots. You're going out and speaking to people. Thank you so much for coming all the way from Africa to speak to us this evening. We're thrilled to have you, and thank you very much to everyone in the room and those people watching on live stream. Thank you, Andrea.
Thank you very much.